we will let Andrew Keys explain what's going on. Andrew.
Best. Thank you all for having me here. It's very nice to be here. This is my first keynote. I've spoken on many panels, and I was given advice when doing my first keynote on an actual new presentation that I've created that I'm to keep my calm. I'm supposed to look at the audience and pretend that you're all naked. And we've got a very good-looking crowd here. So for those of you who don't know me, my name is Satoshi Nakamoto. And if you guys don't know that joke, you should pay attention to this presentation. So I'm going to explain the implications of blockchain and pose that everything that we know about technology is about to change. So here, just for a context, is the amount of Google searches of the term blockchain. Obviously, we can see the exponential increase over the last year. And Goldman Sachs, arguably one of the most powerful investment banks with one of the strongest research analytical teams, creates an annual report called What If? And essentially this forecasts the changes in the world. And I'd like you to read the first page, bold and underline, of that report. What if I told you the blockchain could disrupt everything? And I purposely emphasize this everything because this is not a specific vertical. This is the next generation of the database in a permissioned context, and potentially the next generation of the internet in a permissionless context. This will affect any entity, any vertical that touches databases or the internet. So in order to kind of explain where we're going, I think it's important to give you a historical context. So the creation of the mainframe computer. 1950s, we had big computers the size of, maybe not this room, but the size of a typical room. You had the white lab-coated technicians that created ticker tape with their information. And in the 1970s, I think it was 1972, this gentleman, Edgar F. Codd, created the relational database while working for IBM. Thank you, IBM, for sponsoring this event. So what happened there was this, all of this information that was created on these large mainframes didn't have a place where they could be stored properly. And with the database, we were now able to query information and put it into disseminable layers and able to send this information out in a specific manner. At the same time was the intranet creation. It started in the military as well as universities. So on the top left-hand side in December of '69, Stanford, UCLA, UCSB, and a university in Utah created their first internal intranet. In the 1970s, MIT created a node as well, and those entities were able to speak and transfer information with each other. Come the '89, remember the World Wide Web? My AOL screen name was akeys96. I am still relatively young. That was the first time I ever used the internet, 1996. And what has occurred now is a tremendous amount of centralized institutions working on top of the World Wide Web. And the key takeaway from this is that the database and the internet is siloed. You access databases within centralized institutions on top of the internet, not using a database just on the internet without that intermediary. So it's worked relatively well, but there are problems with the centralization of data. And essentially you can ask, the millions of Greeks who were only able to withdraw 65 euros from their ATM last year. You could ask the customers of Target, JP Morgan, that have their data breached. You can ask the bottom half of the world. I would argue that these centralized intermediaries are garnering tremendous amounts of wealth by really only providing a kind of a thin command line interface. And right now, there's, I think, 80 individuals own enough wealth, or as much wealth, as the bottom 3.5 billion people in the world. So in 2008, interestingly enough, when the capital markets imploded, November of 2008, a pseudonymous figure named Satoshi Nakamoto, who I originally said I was, wrote a white paper, and this person or people are still anonymous to this day. And that white paper was called Bitcoin, the electronic peer-to-peer money protocol. So what is Bitcoin? So essentially what it is it's a decentralized blockchain ledger that helps a person or people or an entity store and transmit value. As of Friday, the total market cap of all of the Bitcoins in population is over $8.5 billion. A single Bitcoin is just under $600, and Bitcoin can do one thing extremely well, which is this transfer and storage of value. I can send you a Bitcoin, you can send it back to me. That's the only thing that Bitcoin can really do today. But it's a very interesting experiment in monetary policy, because essentially we're doing this on a next generation database without that centralized intermediary. We're not doing it with a third-party central bank. So what is a blockchain? It's composed of 5 things. So first is the blockchain database. So a blockchain is a time-stamped, non-repudiable database that contains the entire logged history of the transactions of the system. Next is peer-to-peer networking. Each node on the network is not a client or a server. It's all peer-to-peer. Third is a consensus formation algorithm. Look at how happy these people are. So a consensus mechanism determines the state of a blockchain database as well as the state transition acceptable to the protocol rules. So the transaction processors are often referred to as miners. The cryptographic token. So the cryptographic token is a secure digital unit of account, and it's a medium of exchange and a store of value. So now these tokens play an integral role in the incentivization mechanism. So essentially there are miners in the current major blockchains that basically do math problems for micropayments in order to validate and secure the network. And they receive these cryptographic tokens. In the Bitcoin protocol, it's a Bitcoin, and I'm going to be going into the Ethereum protocol shortly, and that is, that token is Ether. And lastly, the last component of a blockchain is a virtual machine. So a virtual machine enables programmable complete blockchain transactions, and it's the mechanism that can allow for smart contracts-based decentralized applications. The Bitcoin virtual machine is extremely secure and extremely dumbed down. We're just about to talk about the Ethereum virtual machine, but to note, the Ethereum virtual machine is Turing complete. So up until about 2016, there's been about $2 billion in venture capital expended, and that's been expended primarily in the Bitcoin blockchain space. As Bitcoin is a peer-to-peer transfer and storage of value mechanism, that $2 billion has been allocated primarily for 2 things. 1, regulated exchanges, transfer of value, and wallets, storage of value. But there's so much more that we can do with blockchain technologies. So the potential use cases of blockchains are enormous. So a few of them, besides payments, could be the digitization of contracts, decentralized storage, decentralized IoT, escrow, provenance tracking. So for the supply chain management people, the authentication and chain of custody of an asset with a non-repudiable ledger entry is perfect for blockchain technology. the digitization and the tokenization of assets. I spoke with one of the mercantile groups, and gold. If you're a counterparty in America and you want to sell gold on an institutional level, aside from paying the Brinks security trucks to send it to Singapore or to Mexico or to China, in many of the cases, they literally have to melt down the gold. So it's re-standardized and recalibrated in your counterparty's style and framing. Imagine the inefficiencies of that. What we can do now is we can tokenize these assets and put it on an irreputable ledger and have that as a representation of the gold. You can do that with securities. You can do that with rewards points. So enter the Ethereum World Computer. So the Ethereum World Computer is a decentralized platform that runs smart contracts. Those are applications that run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. These apps run on a custom-built blockchain, which is an enormously powerful shared global infrastructure that can move value around and represent the ownership of property. This enables developers to create markets, store registries of debts or promises, move funds in accordance with instructions. The project was crowdfunded in August of 2014, and it was invented by a then college dropout, 19-year-old Vitalik Buterin. To keep this simple, no pretty pictures, I purposely did this in black and white. The internet simplified and expanded human communications. The Ethereum blockchain simplifies and expands our agreements. Ethereum is the next version of the internet. If you think the internet had profound impacts, wait for Ethereum. So the Ethereum crowd raised $18 million in in March of 2014. The current market cap, the first Genesis block of the Ethereum blockchain was July 30th of 2015. The current market cap is over $1 billion. It is less than 9 months old. The market cap has gone from 100 million in January of this year to over 1 billion. The transactions per second are very small. When you look at the comparative transactions of American Express or Visa, 10, 20,000 per second. Right now, in Ethereum version 2.0, we're only at 20 transactions per second. The total venture capital that's been raised basically in this year is already in excess of $200 million. So this shows the transaction chart of Ethereum since the Genesis block. Obviously, we are on a strong and steady increase. And this is just the milestones. So Olympic was the test net. Frontier was the Genesis block. Homestead was essentially the third milestone, and Ethereum improvements. Metropolis is the first step in the scalability roadmap, where we will be going from the proof of work consensus formation algorithm to an unprecedented, newly created proof of stake consensus formation algorithm. And then Serenity will be when we also add in sharding of the address space. And I say we, I'm not doing any of this. The Ethereum Foundation is doing this. And it's important to note, the internet, for all intents and purposes, is governed and run by a nonprofit foundation based out of Switzerland called ICANN. And very similarly, the Ethereum protocol is also run by a nonprofit foundation governed out of Switzerland called the Ethereum Foundation. And the Ethereum Foundation is primarily involved in maintaining the network and dealing with scalability. And the last milestone is called Serenity, where we believe that or the Ethereum Foundation believes that we'll have transactions per second in excess of 1 million per second. So what is the killer app of the Ethereum blockchain, or a blockchain in general? I would pose that it's what is called a smart contract. And I purposely didn't show command line code, partially because I can't understand it, but partially to explain that this will be simple for the lay people. And essentially what this is an if-then statement, and it's basically the sale of a website. So you've got the buyer, the seller, the date, the amount, and if those conditions occur, then the website is sold. So what you're looking at here is the change of going from our traditional prosaic Microsoft Word paper contracts to codified, strictly enforceable smart contracts. So what does this do? This is going to create a lot of soul searching for the middleman, the intermediaries, the entities that get paid to provide trust and intermediation. So an example of one is the DTCC. They settle, there's probably 10,000 people in Jersey City and another 50,000 people in Chennai, India, that settle transactions between banks every day. You can have a smart contract do the same thing. So this is obviously a legacy business, but what about Uber? Same thing. You have disruption to the disruptor. So you can have a piece of smart contract where a driver can say that they're available if X amount is paid for a ride from the passenger, and you can have smart contracts that disintermediate those middlemen. So intermediaries do provide value in some contexts. One of the big things is reputation, kind of the 5 stars in Uber. And now these are kind of those next generation of questions, because it's not just going to be software, quote unquote, running the world. There's going to have to be these touch points, and also explaining kind of the reputation of the passenger as well. So to poke a few holes in this, I can't just tell you it's all rainbows and puppy dogs. Where are the potentials for improvement? So the first one is scalability. Right now, we're at 20 transactions per second. The Bitcoin blockchain is even worse. It's at about 7 transactions per second. The Bitcoin blockchain propagates a new block of information that validates the transactions about every 12 minutes, and the Ethereum blockchain does it in 17 seconds. Privacy. So with the 2.0 version of Ethereum, we don't have homomorphic encryption, and that will be added. Next is energy costs. The amount of energy in these proof of work consensus formation algorithms, these mining farms, the Bitcoin one has the equivalent energy expenditure annually as the country of Ireland. Next is regulation. The total market cap of both the Bitcoin and the Ethereum blockchains is less than 10 billion, which is pennies in kind of the world market cap. And as these things, if these things continue to grow, it's unforeseen what the regulators will do to this. Next is kind of the race to zero. Essentially, if you have these kind of smart contracts, you could essentially copy and paste different types of code, and a 1% fee, instead of paying Uber 25%, could get reduced to a 0.5% fee down to a 0.25% fee. And then next is the enterprise incumbents. The enterprise has been here for a long time, and they're not going to just give over their businesses. So I'm a member of a company called Consensus, and we are the largest Ethereum blockchain shop in the world. We've got about 100 subject matter experts, which is still very small, in mathematics, finance, cryptography, computer science, and just overall blockchain technology. The critical mass of us is actually located in a warehouse in Williamsburg, Brooklyn. And that's about half of us, and about the other 50 are decentralized around the world. And we are a full stack technology company specifically focused on blockchains. And so what I mean by full stack is that we're working at the blockchain space, the infrastructure space, the tool space, the core component space, and the application layer. So Consensus has 3 main thrusts. The first thrust is deep infrastructure and tooling. We maintain 2 of the 7 Ethereum protocols. We maintain the Java client and the Haskell client. And in terms of tooling, we believe that there's going to be certain Lego pieces that are going to be standardized for developers to create this new generation of decentralized applications. So we are building and open sourcing the majority of these, what we call core components. So those things are like identity, wallet systems, reputation systems, kind of those 5 stars that you click on Uber. And in addition to the tooling, we also are trying to drastically reduce the barriers to entry for developers to build these applications. One thing that we've done is we've actually put the Ethereum codebase, Solidity, into Visual Studio, so people can rapidly prototype their smart contract-based applications. So the next thrust is enterprise. I helped drive the enterprise group. And 2016, in my opinion, is the year of the proof of concept for the enterprise. So every board at a Fortune 500 is asking their CTO, what is the blockchain? What does it do to our business hypotheses? And can I have my blockchain in red, or can I have mine in green? And because no one really knows necessarily what this is. And what we've done as a start to this is we've worked with some of the cloud companies, like Microsoft Azure, and some of the container companies, like Red Hat OpenShift and Pivotal Cloud Foundries. And we've essentially put a privatized version of the Ethereum blockchain into those containers or on top of that cloud. And then we have education where we teach engineers kind of what the blockchain is and how to build these smart contracts. And then the last piece are applications. So this next generation World Wide Web's value proposition, in my estimation, is the ability to go peer-to-peer without that intermediary. So here's an example of one of those applications. Grammy Award singer-songwriter Imogen Heap was sick of her record labels and sick of the professional rights organizations that took 30% of her revenue and 3 to 6 months in order to pay her. She uploaded a song onto the Ethereum blockchain. The song cost 60 cents, and peer-to-peer, a fan could purchase that song. 17 seconds later, the fan would have that song, similar to if they used iTunes or Spotify, and of the 60 cents, 1 penny went to the smart contract, or 1%, excuse me, went to the smart contract. 92% of the 60 cents went to Imogen's account. 1% went to the drummer. 1% went to the bass player. 1% went to the guitarist. Very granularized smart contracts. Now that same exact peer-to-peer infrastructure, we tokenized and sold a peer-to-peer electron. This happened last month in Park Slope, Brooklyn, where Alice was on one side of the street and Bob was on the other side of the street. And Alice had a photovoltaic array, a solar panel on her roof, and in a Ethereum smart meter that we created basically the technology for, she was able to garner her tokenized electron and sell a renewable energy credit peer-to-peer to Bob across the street. So one other piece that I want to talk about are those core components, because one of the value propositions that the intermediaries have are providing things like wallet, like a bank, reputation systems, like those 5 stars on Uber, registry systems. So one of the most important ones that I think is the concept of self-sovereign identity. Right now, Mark Zuckerberg, Sergey Brin, Larry Page, the owners of Facebook and Google respectively, they quote unquote own our self-sovereign or our digital identity. We use Facebook as that repository. Facebook gets paid millions of dollars a day for the advertising, and potentially we have those digital assets that are susceptible to hacking. Not to mention the 1.5 billion people of the 7 billion people on Earth that don't even have an identity, technically. So in this concept, Andrew goes to the bank authenticates who Andrew is, and then the bank gives Andrew his money. So in the same way, we've created, it's called UPort, which is a portal authenticator. And you can imagine this in this kind of new next generation internet, a new paradigm where the wallet is the browser. And I'll just let that kind of sink in for a second, because that's what is going to kind of evolve in this next generation decentralized World Wide Web. And every storage or computational step is going to take a micropayment, which is that ether, to prevent loops. But with this, we create our own identity. And we hold all of those assets of the identity. So I can now have a canonical persona, and I can have an attribute of that canonical persona that's verified by the state of New York, that I am indeed Andrew. So that could be my driver's license. And now we can also have attestations. And attestations are basically people or entities attesting to my conduct. So this could be Deutsche Bank saying that I indeed passed my anti-money laundering know your client. This could be that Uber 5 stars again. So basically these next generation wallets don't only hold the money, but they hold the attributes and attestations. You can also imagine in a developing country, when a baby has a vaccination, they could then have an electronic medical record created at that same time. So to help thwart kind of the human trafficking and human crimes for that 1.5 billion that don't have a digital identity. And that's put into this non-reputable world computer. So this is just a little taste of kind of our ecosystem. We're working with many enterprises. We are part of the Hyperledger project, which is the open source Linux Foundations project. We're dealing with many of the blue chips, and we're building a lot of these applications. Specifically to cloud, I helped co-create with Microsoft Ethereum blockchain as a service. So essentially, it's a single-click deployment where technology groups can spin up a private enterprise blockchain. And essentially, what I'm posing is that you're going to see lots of blockchains. Each private company is going to have their own private blockchain, and then there may be consortiums where two counterparties interact on a blockchain. And then there may be business logic that splays into this public blockchain. So right now, a lot of the regulated industry is healthcare, regulated by HIPAA. Security is regulated by FINRA. They're not necessarily ready for the public network due to kind of A, the scaling concerns, B, the miners validating the transactions, because essentially any miner can join the network, and I think there's a lot of education because you may not want an anonymous entity to validate a transaction for you, and I don't think the SEC would be open to that just yet. So basically what we've seen in the enterprise is that a lot of them are very interested in these kind of testing applications that can go into full-scale cloud-based production environments. So the last point I'm going to leave you with is this cover of The Economist. And the title says, "How the Technology Behind Bitcoin Could Change the World," explaining the trust machine. And so what will you build on Ethereum? Thank you.